Hello, everybody. But your presence is very few. What about others? Can anyone say, or you can inform them in your group or Mohammed, can you hear me? Atiku, Yahya, Rabian, Said, or Usman. Are you hearing?
Yes, sir, we are hearing you.
Yeah. What about others? Send them message to connect. Okay.
Okay, sir.
Okay. We'll begin after 2 minutes. Okay. Send or communicate with them so that they can Let's get started. Those who are not available right now, hope they will go through the records and they will learn things. Okay. Today, we are going to discuss about software-defined networking. It is a new paradigm in networking. Over the period, network has evolved to virtualize environment, and the final or the latest development is software-defined networking, which is state-of-the-art networking technologies for enterprise and data center. Okay, software-defined networking use software-based controller or API to communicate with underlying hardware infrastructure and direct traffic on a network. So network programmability is the most central concept of SDN. So what SDN looks like in this diagram, you can see there is a network and they have different connectivity and they are connected to controller. Okay, controller can be more than one for redundancy, but at least one controller is required for this. Okay, this controller is used for centralized monitoring and enforcing different policies. What are the benefits of SDN? SDN is a centralized management system and different configurations can be done from a single pane of glass from controller, and it's a dynamic system based on the requirements of traffic. It will change different policies or controls. Okay. This type of network can load balance traffic because in traditional network, if we use layer 2, there is a spanning tree protocol. Spanning tree protocol blocks some lanes for preventing loop. But in this type of topology or networking architecture, all the links are utilized in a load balancing manner, and it is fault tolerant. That means if one link is down, it will dynamically reroute traffic to other links. So it is fault tolerant. So to understand the software-defined network, why software-defined network evolved, you have to understand three different planes of network. Although we have a physical network, we can logically divide them in three planes. Okay, one is management plane, one is control plane, and another is data plane or forwarding plane. What is management plane? The name implies that it is management of device. Okay. We manage networking devices such as routers, switches, using SSH, Telnet, HTTP, HTTPS, or collect logs using syslog, as we use SNMP, Simple Network Management Protocol, for collecting information about configuration and latest condition of the device. Okay, SNMP is used. So all these protocols are used in management plan, just for managing your devices. So it is pretty straightforward to understand. And then we have control plane. Control plane is the plane where it controls data plane or data transfer. Let's say we used different routing protocols, OSPF, EIGRP, REAP, BGP, IP version. Sorry, here is a mistake. IP version on 4 and IP version ARP and neighbor discovery protocol, MAC learning, SNMP protocol, etc. are actually controlling our traffic. Okay. So this is this type of activities or areas are known as control plane. And then we have data plane or forwarding plane. So what is forwarding plane? Forwarding plane just forwards your data, just forward your data from one point to another based on control plane decision. Okay, or control planes control. Okay, how this happens? From router 1 to router 2, traffic will pass. So how it will be passed based on control plane routing protocols, routing table. Okay, so in the routing table, there is a route for this type of traffic. Okay, in that case, traffic will be passed forwarded based on control planes routing table here in router. Okay, that is why data plane or forwarding plane is dependent on control plane, and they are interrelated. So what we can see, what are happening in data plane. So in data plane, encapsulation, recapsulation, decapsulation, and the forwarding the data from one source to another. This type of activities are happening in data plane. So here is a list. Okay, for example, data encapsulate, decapsulate, re-encapsulate packet in a data link thread. Okay, so this is a forwarding plane activity. So in case of trunk, we can see that 802.1q headers are added or removed. So that is also forwarding plane or data planes activity. And matching an Ethernet frame destination, media access to MAC address table at layer 2 switch. That is also layer forwarding plane. And matching IP address, IP packet destination, and forwarding it to a specific route. That is also data plane. Okay, the just packets destination IP is maps and it looks which route should follow. Okay, then pass. Okay, then encrypting the data and adding new IP header. In case of VPN, okay, that is also data plane activity. Changing the source or destination IP address in network address translation, that is also data plane activity. Discarding a message due to filter. So you have ACL for ACL action can be denied or drop. In that case, discarding or denying a port or IP packet is also forwarding plane activity. You have to really understand what actions are being happen in each in plane in each of the three planes. Okay, so what I mentioned again, repeat it: management plane and control plane and forwarding plane or data plane. Okay, we have three planes. So in network, we can divide them in logical three parts, three areas. Okay, so we always consider in three areas. In that case, it will be easier for you to understand to manage the whole network. A management plane where you are managing your device. Okay, and control plane is where you have some controlling mechanism. Say routing protocols are used for controlling your traffic because which traffic would take which road depends on routing protocols control and the spanning tree in layer 2 to control or stop loops in the network. We use spanning tree for this type of control. So all these type of protocols are actually are being used for controlling of your traffic or traffic means data plane activity. Okay, in data plane, your actual data are being transferred based on the control plane. Okay, what are the controlling mechanisms are routing table or forwarding table, but that is created by control plane, and it has ARP address resolution protocol. What is address resolution protocol? Address resolution protocol is when one device want to connect another device based on IP address, they need layer to MAC address. So they use address resolution protocol to get mapping between MAC address and IP address. So from ARP table, the message transfer is possible based on layer to frame for destination MAC address are used for that communication. Okay. So all these type of activities are based on control plane. So look how control plane and data plane are working in concert. Okay. Look, there are three routers, R1, R2, R3. So packets are arriving in data plane, and then these packets are transferred to other router. So how this is controlled? So between the routers, OSPF routing protocol is being used. So OSPF is a controlling mechanism for data plane. So OSPF router creates routing protocol, and that routing protocol guides router how to forward data to other router or device. Okay, so control plane is controlling, and data plane or forwarding plane is just forwarding based on control. So just remember. So if you go through this material, I think it will be easier. Okay, I just summarize. Then it is what would be the three plane at the same time if you look at them. Okay, there is management plane at the top. At the top, do you have any questions or anything? Okay. Okay, you are joining. It's good. That's good. And hope you can contact with your fellow trainees. Then they will also join. Okay. Okay, we have management plane. Management plane is just SSH, Telnet, SNMP, syslog, etc. Just used for management of your devices, router, switch, firewall, or whatever devices you have. You have some control. You need to manage them. For management, you are working in management plane. It is pretty straightforward. But for some, control plane and data plane may be confusing sometime, or in the test, for example, there are some questions regarding which actions belongs to which plane. Say, a router is sending a packet based on access control list, or allowing a port allowing a port which this action which is belongs to which plane. Okay, this type of question may arise or may come. So in that case, you have to decide which plane is relevant to this action. So you have to clear, and you will be clear just reading these slides, or you can read books if you want to get more detail. So why we are discussing different planes while our topic is software-defined networking. So to understand software-defined networking, we have to understand these three planes, because originally software-defined networking was developed based on the concept that our control plane will be in a central controller instead of different devices. Okay, in our previous look at this picture, you can see that every router 1, router 2, router 3 has its control plane, its data plane, and also management plane. But SDN developed to to take those control planes to a central location. Only data plane will be on the router or device. Only data plane will be on the device's control plane, and also management things are also from a central controller. So this is the concept. So controllers and centralized control. So everything will be controlled from a controller, which is at a central place, from where you will configure your devices, you will create policies, different traffic policies, and enforce them from there. So say kind of programming. Okay. That is why network programmability is required here. So you can program using different techniques. Generally, we manage the whole network using graphical user interface, but there are also options to program. So if you can write some program for some automation or any customization, you can do that. That is the flexibility of your SDN, software-defined network. Okay. So software-defined networking is used at data centers. At modern data centers, software-defined networking are used. Traditional networking are also used in some data centers. So in the last session, we discussed different network architecture. Maybe not last, just okay. An earlier session, we discussed network architecture. One of the architecture was 3-tier or 2-tier network design and for LAN. But that is also used in data center. But this type of 2-tier and 3-tier are actually inefficient in case of modern virtualized data center. So SDN, software-defined networking, are being used in modern data centers. Okay. This type of networking techniques are used in, but these type of deployments are also rare. Say in our country, Bangladesh, there may be few deployments of SDN different data centers, but they are not widely used because they are very sophisticated and complex configuration and skilled people who know to manage or configure software-defined network are also not available. Okay. So software-defined networking is the concept. Look at this picture. There are different devices, network devices. There are 3 networking devices, and all networking devices are connected to a central controller. Okay. And look, control plane is crossed. That means control plane is transferred to controller, central controller. Only data planes are on the device. So this is the main concept of controllers and centralized control. Okay. Can you understand this concept, or you're finding a bit different? What about Tariq Khalid? What about Fatoumata Conte?
Yes, sir.
Can you understand the concepts or finding quite difficult? Or if you need, then I can repeat or explain further so that you can. Actually, software-defined networking is quite a difficult concept because all the things are actually virtual. Okay, in the traditional networking, router switch are all physical, and everything we do is quite straightforward. But in SDN, although there are physical devices are involved, but we have to understand all the virtual things. But remember, if you will be in professional environment, you will encounter different virtualization technologies. That means virtual networking and software-defined networking will be very common nowadays. So it is important topic. In the past, when we studied CCNA long ago, we had no software-defined network because it was not that common. It was only in CCNP level or CCIE expert level courses. But now everything are introduced because this type of technologies are actually new normal. Okay. So you will get and you have to work with them if you are in networking domain. So software-defined network. In fact, when we are using cloud, we have different networking configuration. And in the cloud, that is also virtual network, or everything is software delivered, and this type of SDN is actually used behind the cloud. Cloud service providers have their own data centers. This data center is totally controlled by software defined. So we call SDDC, software defined data centers. Total. Nowadays, everything, every data center are becoming software defined. So software-defined storage, software-defined data center, software-defined networking, and you will see the term SDX, software-defined X. That means X means anything. Software-defined network, software-defined storage, software-defined server. Okay. Okay, what I was starting that control plane is moving to controller. This is the central concept of this type of controller-based software-defined network. And then, so how they control the devices from controller? So they use southbound interface or API. API means application programming interface. If you are working with software or application, you will be familiar with API. API are common nowadays because microservices are being popular.
Class bitakan.
Okay.
Class bitakan.
You may ask one question maybe. I'm not clear. Can you repeat? I'm not sure. Okay. Anyway, so API is covered in case of application development. In the past, communication between one application to another application was quite difficult, and there were different mechanisms that was a bit difficult or sometimes proprietary. Nowadays, APIs are quite straightforward. You may develop an application in say C++, and someone else has developed another application that is in Python, and another one maybe with Java. Say. So what if you want to communicate between those applications? Okay. For example, one application's output may be input of another application's output input. So in that case, you may need to transfer data from one application to another application, where we use API. So here also API is used to for communication between controller and devices. Okay. So this is there are two types of API in case of SDN. Southbound API or interface, another is northbound. Okay. So two types of APIs are used. So what are the difference between them? So southbound API is used for communication between controller and device. Okay. And then you have northbound API. So sometimes you may have an application, and with this application, you may want to communicate with SDN controller. So why you communicate? For example, you want to get some information from controller, or such as log collection or anything. So that application will communicate with the controller using northbound API. So two terms are used, northbound and southbound. You should understand. Another term with regard to direction somehow. There are two types of traffic in a data center. In a data center, you may have many servers, virtual servers or physical servers, whatever. There are some data transfers are happening between servers inside the data center, and some data transfer are happening inside data center to outside client or server. So there are two types of data transfer or communication. So in case of inside data center server to server data communication, we call it east-west traffic. And when data is transferred from inside data center to or from another entity or device outside the data center, that is called north-south traffic. So there are direction related to some terminology in the data center. Okay. Here we are talking about northbound interface or API and southbound. Okay, you have to remember it. it is important. Okay. Then there are examples of HDN. Different types of HDNs are developed. Open daylight controller it was actually open source HDN controller. Okay, Cisco has its own version of open source HDN controller, Open Daylight. Okay, that can also be used. That is commercial version. And which is the most popular HDN is Cisco Application Centric Infrastructure. Cisco ACI is the most sophisticated and widely used, I would say, data center networking solution, and that is called Cisco ACI. Okay. Then Cisco Application Programming and Interface Controller or Enterprise Module (EM). But this type of solution was developed for enterprise LAN, for example, but that is not used that much, and now they have deprecated it. Okay, so based on the concept, they developed Cisco DNA, Cisco Digital Network Architecture, and Cisco SDA, Software Defined Access. Okay. So we'll discuss them also here, but we will mostly focus on Cisco ACI, Open Daylight Controller or Open Source SDN, and will not be discussed here. Okay. So what is the ACI? ACI is application-centric infrastructure. It is used for modern data center networking. So its name is interesting. Application-centric infrastructure means networking will be focusing on application. That means application. What is data center? In the data center, there are different applications running on different servers, and there are also data storage. Okay. As different applications are the main concern for your business, that is why your network is also application centric. That means focusing on application. So networking system developed for the best experience of application. Okay. So what is the architecture of this network? This network is quite different from the 2-tier or 3-tier network we discussed earlier. Although we mentioned that 2-tier and 3-tier networks are for campus network. Okay, in fact, that architecture is also used in data center traditionally. Okay, but most modern data center don't use that architecture because they are not that efficient, and traffic cannot be controlled by that architectures. Okay, you have some control, but not that much. With application-centric infrastructure, you will be able to control different applications and traffic as you want. Okay, you will be able to control more at a more granular level. Okay, that means you will be able to control them at a very low level. So everything is under control. Under your control. Okay. What is the architecture? Architecture is it uses a central controller. Okay, SDN. One network will be SDN if it has centralized control. A device, it can be physical appliance or a virtual appliance that can be installed on a virtual machine or computer. So in case of Cisco SCI, EPIC is used. EPIC, what is EPIC? Application Policy Infrastructure Controller. Okay, EPIC is not shown in this diagram, but what we are showing the architecture. The architecture is called spine and leaf. Okay, spine, as its name, you know what is the spine. Spine is the central part of the network here, and the leaf, as its name implies, is the leaves of a tree. Imagine. So leaves are another devices which are directly connected to different servers or devices or other network systems. Okay, but a spine will not be connected to any external host. They will only connect to leaves. Even a spine to spine connection or leaf to leaf connection is not connections are not allowed. Okay, so it is interesting. Interesting architecture. So from any wire to anywhere, the distance is same. That means if one leaf is connected to some devices and another is with another devices, they just go through this leaf to spine and then another leaf. Okay. So between leaves, there is no connectivity. On this spine is connected. So traffic from one leaf to another will be passing through spine, one spine. Okay, this is the interesting and efficient way of HDN. Okay. So what are the rules of connectivity for spine and leaf? Each leaf switch must connect to every spine. Each spine must connect to leaf. Leaf switch cannot connect to each other. Spine switch cannot connect to each other. Endpoints connect only to leaf switches. Okay. Look at this picture. There are spines and leaf, and all the leaves are connected to different. Say you have an external router for ISP connectivity. In that case, it is connected to leaf, not a spine. And you have physical server, you have virtual server, UCS, is Cisco server. Okay, that is in this server. There is also virtual switch. Virtual switch connected to leaf, and all the leaf switches are connected to spines. Okay, and there are redundant connections. Another interesting thing is all spines are connected to a leaf switch. Okay, there are three spine. Okay, you are connecting three connections. Okay, there are three connections with three spines. Okay, so in case your device is disconnected from one spine, no problem. Another two will be there. If two are disconnected, another one will be there. So in this way, you can ensure resilience. So and more reliable data center. So what are you doing when your data center
Metaverse tu bana.
what
Kasi
is-
bana video aku bana ini semua tak di real ka. Wala di picture.
mute or silent?
Ah.
Okay. Okay. What I am trying to say is that when your data center grows, so initially you can start with two spine and some leaf switches with your network, but your servers are added to the data center. Existing leaf switches are not capable of catering those connectivity. Okay, so you will install more leaf switches and connect to a spine. If the spines are not capable of catering leaf switches, in that case you will add more spine switches. So it is quite easier to scale. That means when your data center is increasing in capacity or size, in that case you can increase your network without changing other devices. It is easy to scale. Scalability is another important aspect of Cisco SCI. Okay. So why this type of network is popular are for modern data centers or cloud-based virtualized and cloud environment, because we can create different policies in the controller easily and enforce them also easily. So let's discuss with web application, not web application, application. Say you have a three-tier or three-tier application. What is three-tier? Three-tier is one layer or one tier is database. So database is one server, one or more servers for redundancy. And then you have application or business logic, where your main business logic or processing is done. And then you have web application, where your front end application is configured. That means you have three types of servers for one application. So there are also multiple servers in each category. So there may be 3 database for redundancy or another purposes. There may be 2 application, or if one application fails, another will take lead, and you may have more than one web application, and that is directly accessing data directly accessed by your clients or users. So it will go to your network router or external devices are connected. So look in this diagram. So applications will connect to database, but database has no other connectivity to, say, web application has no direct connection to DB, or in the network, there will be no other devices that are connecting to this DB. But in traditional architecture, your databases are also connected to network, and the devices that are in the same VLAN can connect to that database server. So it is a security risk. Sometimes it is the reason why malicious actors or hackers can connect. Okay. So okay. But in Cisco ACI, we can apply create policies so that only applications can connect to databases, and web applications can only communicate with application servers and external devices, external systems. As web applications are actually open to the world, okay, open to internet. So it will be allowed for internet access. But applications has only connectivity to database and web application and nothing else. Okay. So all these things can be easily controlled in Cisco ACI. Here EPG, endpoint group, are created. So database are a kind of endpoint group, applications are another endpoint group, and web applications are another endpoint group, and external router 1, 2, for example, is external group. So we can enforce policy to allow or disallow their communication based on the application. But in traditional 2-tier or 3-tier network for data center can also provide this type of control, but with huge configuration or effort. But easily that is not possible in the traditional data centers. So Cisco ACI is used for this type of modern data center. Okay. Okay. Can you understand or anything you can ask me? Can you hear me actually, or you are? Okay. And then how we can control this. So at the top of this figure, you are saying the AP, application programming interface controller. So the bottom, you are seeing the devices, network devices, 3 network devices, for example, and you are seeing that each network device is control plane and data plane. But control plane is actually in the network here in Cisco's deployment. All the original SDN concept, control plane is totally in the controller, not in the device. So that is the differences in Cisco SCIN and original concept of software-defined networking. So there is a little difference. Okay. So here another concept is to develop intent-based networking. Intent means your intention on about the network, what you are trying to do with your network. That is called intent. Cisco are using intent-based networking from application programming interface controller, APIC controller. You are creating some policies that will be transferred to the device's control plane. Based on your policies, this control plane will configure themselves to control data plane traffic. Okay, this is actually intent based. Just controller is sending intent or intention. Okay, they are not directly controlling this. Okay, in the traditional routers and switch, we just configured what will be the routing protocol, which port will be enabled or disabled, etc. Okay, we just clearly mentioned, or in a statement of network command or a statement, we mention everything clearly and execute on each router or switch. But in this type of network, we are not configuring the routers and switches. Actually, routers are not used in this. They're called switch, but switch has routing capability. In fact, layer 3 switch and routers, and they are very costly and very sophisticated switches are used. Say Cisco Nexus 9000 series is very robust networking device. Okay, so what is happening? OPLEX is a protocol that is used between controller and devices for communication. So you are defining your policies in the controller, and these policies reflect your intention about the network traffic, and that intention is transferred to the devices, and devices control plane will be set according to your intention. Okay, as you wish, I would say. Okay, according to your wish, your devices control plane will be managed. Okay, but you are not directly control or give any command or write anything, routing port command. Everything will be from intention. Okay, intent-based network. So look at this figure, this is a AP controller and Oplex is used for communication. ACI data center with Nexus 9000 switches. And virtualization software, cloud software, automation software, graphical user interface, and scripts or programmability. You can use Python, for example, for controlling your controller. So all these facilities are there in the AP controller, which is communicating with its network fabric. Okay, here another concept is fabric. Fabric is saying that when many things are connected to form another thing, which is called fabric. Okay. So in SDN, everything is connected to form and form a fabric. Okay, and this fabric is controlled by controller. Okay. So this is Cisco HCI data center. Okay, data center is a simplified diagram. Okay. So there are differences between different deployments of SDN. An OpenFlow is open source SDN, and Cisco ACI, then Cisco EPIC Enterprise module. But EPIC Enterprise module is not in use. It has changed its name and modified to another technology. Okay, but based on this concept mostly. So what are the differences? Changes how device control plane versus traditional networking. Okay, often yes, there are changes in OpenFlow and ACI, but APIC Enterprise, there is no differences. Control plane are all still in the devices. Okay, but in ACI, there are also but there are changes. Because changes in the sense that all the control plane activities are also in the device, but this control is totally from controller and centralized point from which humans and automation control the network. All three deployments are using controller, SDN controller. So from here, every control activities are performed. Degree to which architecture centralize the control plane. Okay, control plane centralization is in OpenFlow, but not 100%, but mostly. But in ACI, you see that only partial control plane activities are taken to controller. They are still in the device, but EPIC Enterprise system, all the control plane is in the device, not at SDN. Then southbound interfaces are used. What type of southbound APIs or interfaces are used? OpenFlow is used for OpenFlow, and Oplex is a version of OpenFlow is used in Cisco ACI, CLI command line interface, SSH, Telnet, and SNMP are used in EPIC Enterprise. Okay, controllers mentioned in this book. Okay, what are the name of SDN controller? Open close SDN controller's name is Open Daylight. Okay. For ACI, just mentioned APIC, Cisco Application Programming Interface Controller. And enterprise EM, it has EPIC EM. Okay, organization that is primary, define, or owner. So who developed those type of technologies? So OpenFlow is developed by Open Network Foundation, ONF, and Cisco develops ACI and EPIC enterprise. So if you go to ONF's website, you will learn more about open source SDN. Okay. So okay. Can you be clear about the concepts or anything to further elaborate? Okay. Okay, what about Atiku? Can you understand? What about Nazneen? Are you hearing or just?
Yes, sir.
Can you understand these concepts of
So yes, it is understandable, but this topic is new for me. That's why I need to read.
Not only for you. I think for most it will be new. But just understand all the topic. There is no option for any lab because these are so sophisticated that labs are not available. Maybe some lab service providers are there who can provide, but that's also expensive and only used by those persons who want to actually learn for real implementation and for Cisco advanced level examination. Okay. So at least if you understand at high level, that is enough. For command level, okay, it's not that issue. When you try to really work, then you will be able to learn. If you know the high level or the bird's eye view, it will be easier for you when you actually work with this type of technology. And then you will know okay, why I am doing this. Okay, for I know high level why I am doing this. If you don't know from top level, then sometimes you will be puzzled. Why I am doing this? Why I am doing with this part? Because when people work in a team, they are not working with the whole network. With whole network, architects who are network architects, the thing, but for team members, they work at certain areas. Okay, that is the thing. Okay.
Sir.
Okay. Okay.
Sir.
Yes.
Sir, yesterday I was disconnected after 1 hour. Your classes for some reason. That's why, sir, I didn't download your file that you are uploaded in that class.
No, actually, I uploaded all the files in the cloud, in the Google Drive.
Sir, is there any link that I can access this link? Then I will get this all of this file.
Okay, I can share the link again. Okay, I'm sharing. Let me do it. 1 minute. I'm sharing. That link. Companion function. Okay, those who fail to copy the Google Drive's link yesterday, you can get the link, and all the materials are there in the drive. Okay, let me share again. Let me share. Okay. Okay, then another area is actually Cisco software defined access. In the traditional networking, on the traditional networking, we discuss different architecture, 2-tier, 3-tier, or network architecture in a network for access. Okay, but here is also concept of software defined networking, which is called Cisco SDA, software defined access. SDA uses software defined architecture model at the center, a digital network architecture DNA center controller. Okay, in data center we use EPIC controller for Cisco's deployment of SDN, and in case of SDA we are using DNA center. Okay, DNSC. So here is 3 concepts are also introduced in. Actually, these 3 concepts are also in the data center networking or in the Cisco ACI. Okay, but we skip. But in SDA, we are discussing these 3 concepts. One I already mentioned, the fabric. Fabric is this network. Whole network is actually fabric. Okay. And we have underlay, we have overlay network. Okay. So what are underlay and overlay? Underlay means all the devices, physical devices that are used for connectivity or networking. Okay, there's an underlay network. So you have to ensure connectivity and all these things, everything for network devices. Based on this device or network, you are creating a virtual network, which is actually overlay network. Okay. Overlay is totally logical. Okay. And that overlay is actually used for different different servers or systems connectivity. Okay. But in physical network, just router switch we can configure, and just those are directly communicating with each other, and your traffic is passing, okay, directly. It's pretty straightforward. But here is another layer of networking. Okay, so another network comes into play is VXLAN. So you heard VLAN, which is virtual LAN. Virtual LAN is used for segregating or dividing your LAN into some virtual or different LANs for different purposes, which are quite isolated by default. Okay, that are VLAN. But how many VLANs are possible in your LAN? It is 4096. Okay, 4096. That means around 4,000 plus VLAN are possible in your LAN or in your data center with VLAN. So this is a great limitation these days. Initially, the VLAN was developed for this type of with this type of figure, which is very small number if we consider a huge network. Imagine Amazon Web Services data center. So 4096 or 4,000 value is sufficient. Is it sufficient for them? No. They need even millions of segregation. So how they can do it? So another concept is VXLAN and came, which is called virtual extensible LAN. Okay. So VXLAN is used in overlay network. In fact, layer 2 traffic is transferred over layer 3 network using VXLAN. That is very interesting. So VXLAN tunneling protocol is used in overlay. Another traffic is LIS, which is locator identifier protocol. We will discuss. So what is actually underlay network? Look at the figure. You can see in the bottom figure, you can see that there is a network which are physically connected, different switches, which are actually layer 3 capabilities, which has routing capability. Okay. So these are connected with cables, etc. This is underlaid. Based on this, we have a VXLAN tunneling network between two devices. Okay, say you have one server or one device connected to switch 1, another computer or device is connected to switch 2. You want to communicate between them. What you will do, you will use VXLAN. Of course, you can also use VLAN for different devices, but those VLANs are actually local. Say switch one has two computers in this, they may be in two VLANs, but those VLANs are actually locally significant. We will not trunk them. Okay. So those devices will be tunneled through a VXLAN tunnel. Okay, that is overlay network. Overlay network means you have something underneath, and based on this, you are creating something. Okay. Okay. So the architecture of software-defined access is like this. So you have underneath underlay network. This underlay network is connected to DNA center, a digital network architecture, is the elaboration of DNA. And this DNA controls, DNA center controls your underlay network using Telnet, SHS, SNMP, NetComp, RESTComp. So two new concepts are there. Okay, two new protocols are there. So what is the use of DNS center? People are using GUI for controlling or configuring the DNA, and DNA will indirectly control the fabric or network. And you can also do some script or program, okay, to control using REST API. We'll discuss REST API later, and other vendor or third party can also manage devices. Okay. So here is also DNA also use northbound and southbound interface. You know what is northbound and southbound? Northbound is used for communication between different application and your DNA center or controller. Okay, and southbound is used for DNA communication between DNA center and your network device. So broadly speaking, there are two groups of southbound APIs that are being used, API or interface actually, okay, are used by software-defined network, software-defined access, or DNA center. So traditional, there are some devices that do not support NetComp or RESTComp. Okay, they use SHS, Telnet, and SNMP, this kind of protocols. Okay, but recent or newer devices support NetComp and RESTComp protocols or communication. Okay, so these are new to you. Okay, so what are the differences between traditional networking and software-defined network access? Okay. Why software-defined networks are becoming popular or considered more efficient and effective and suitable? So look at the two figures, you will understand the differences or benefits. So on the left side, you are seeing a small network with 3 switches. You have one switch which may be layer 2 switch that is directly connected to computer, and you have 2 switches at distribution layer. So it is 2-tier network design, and which has a layer 3 switch routing capability. So you are connecting your host to switch 3, and there are also switch 1 and switch 2. So switch 1 and switch 2 are layer 3 capabilities. They have gateway. Gateway is on the distribution layer, and they are using HSRP, hot standby routing protocol for redundancy. Okay. I discussed also also provided a lab in this regard, in this type of protocol. So your gateway is in this distribution layer switch, but you have another two connectivity with your access switch. You have 2 connectivity between access switch and distribution switches for redundancy. But their rapid spanning tree protocol is working to prevent loop. So what STP is doing here is just blocking one link. Okay, it has logically cut one link, and your traffic is passing through one link only, and another link is actually idle. So it is the wastage of resources. Okay. Software-defined network solves 2 problems. Look, just replace one switch at access layer. Sorry, replace with layer 3 switch, and now gateway is in layer 3 switch. Okay, directly in access layer. Okay. Now gateway hot standby routing protocol is not required here. Okay, so it is simplified. Another benefit is that the spanning tree protocol is not working. You know, a spanning tree or rapid spanning tree protocol works at layer 2 of TCP/IP network. Okay, but instead of layer 2 connection, it has improved to layer 3. That means all the devices are working as a router, and routing protocol is working in this network. So ISIS routing, intermediate system to intermediate system routing, or you can run OSPF, but ISIS routing is used mostly in software-defined network because it has some advanced benefit, however. So now both links are in active mode, and they are carrying traffic. Okay, so all links are used at layer 3, but they can pass layer 2 frames through layer 3 network using VXLAN tunneling protocol. That means it encapsulates your layer 2 frame and then pass in the VXLAN tunnel to other switch, and that switch will then de-encapsulate VXLAN tunneling headers and pass to the device with a layer 2 frame. So it is very interesting thing. Usually layer 3 in normal network, what is happening? Layer 3 packets are encapsulated in layer 2 frame. Actually, layer 2 frame is this, just addition of headers, layer 2 headers with packet, layer 3 packet. Then it becomes layer 2 frame. So here it is quite reverse, just reverse. You have a frame, you are not doing with anything with the frame, just encapsulate and pass through VXLAN tunnel at layer 3, and at the other end it again becomes layer 2 frame. Look at this diagram. It is the diagram how VXLAN protocol is used by SDA. Actually, same mechanism is used by Cisco SCI or data center network. Okay, same technique. So look, there are two servers or the two computers. One has IP address 10.1.1, another has 10.1.2.2. Okay, and there is a fabric, and in the fabric you have one ingress node or switch, and there is also egress fabric. What is ingress? Ingress means so your traffic is entering to a device. Egress means your traffic is leaving your device. So how VXLAN encapsulation is performed in the network. So you have LAN frame or layer 2 frame, and that is attached with a VXLAN header and then UDP, then IP address. IP address for layer 3 passing. Okay. So there is a tunnel, there will be a tunnel between the switch 1 and 2 using VXLAN. Okay. So VXLAN protocol encapsulate layer 2 frame and pass through the fabric, and at the egress point, it will remove IP, UDP, and VXLAN header. So layer LAN frame or layer 2 frame again appears to the receiving host. So PC1 and PC2 sees them in the switch. They appear so the network appears to them as a switch. They do not know what is happening inside the fabric. Okay, it is like you are sending a parcel or letter to your family, for example, or friend. When you are sending this parcel or letter, you go to courier service or post office, and you will give them So what they will do with your parcel or letter or envelope, they will do different things. They will collect from many people's letter or parcel and keep them in a bag, in a large bag or box. Then they will put that bag in a truck or lorry, and then they will send them to your destination district or area, and there they will distribute, and there are many people working. Okay, so and after that process, they will deliver it to the destination or recipient, and recipient will see only the package that you sent. Okay, he or she will not see what is happening between you and them. Okay, they'll just receive the packet. The same thing happens here. Okay, so one computer is just sending the package, and another one is just receiving the layer to print. So what is happening between them is not known to them, and this is not their issue. They just process with layer to frame. Okay, VXLAN is data center networking technologies nowadays. You have to understand this protocol. It is quite new, and you have to give some effort to understand the networking. Okay, it is based on encapsulation, de-encapsulation techniques. Okay, at ingress point, it is using encapsulation. At the receiving egress switch or node, it is just de-encapsulation or decapsulation process happen, and your traffic is passed. Okay, so it is overlay network. So this type of network is happening just underneath. There is a network. Okay. Okay, then what is the network? Okay, for VXLAN, and VXLAN is actually a data plane in the software-defined network. Okay, a data plane in the sense that VXLAN's purpose is to pass your data, not the control. Okay, look in the picture right side in the figure left on the right hand side. This is layer 3 network, the fabric, and here we are using a routing protocol ISIS. That is the control plane mechanism. Okay, it is not actually data plane activity. VXLAN purposes is to just pass. So this is fabric. Look at this. It is the underlay network, but it has some connectivity. Okay, they are, but VXLAN is used to create another network based on this network. Okay, so it is VXLAN. VXLAN has another IP addressing, maybe. Okay, here is 172 series IP address. Okay, but look, for VXLAN, we are using 10 series IP. Okay, or class A. And look, another differences. VXLAN nodes has an IP series in class A, and node actual devices, endpoints. Actually, write language for different things. Endpoint is actually computers, devices, your mobile, your laptop, tablet, or servers are also actually endpoint. Okay. So in a word, endpoint term is commonly used nowadays, and we should use it because if you use endpoint word, then we don't need to mention whether it is server or anything. Where we don't need to mention or classify those devices. Okay, we are concerned with our network. Okay, so with network, different things can be connected, servers or client device. Okay, whatever endpoint. So endpoints have different series of IP addresses of class A. Okay, they are passing our VXLAN. They are passing the traffic over VXLAN. Okay, so it is data plane network. Another protocol that is quite new, not quite new, totally new protocol. It is used in modern latest software-defined networking. Locator identification separation protocol LIS. Okay, is a routing architecture that provides new semantics for IP addressing. The current IP routing addressing architecture uses single numbering space IP address and express two features of information: device identity, the way a device attached to the network. Okay, IP. Why you use IP address? IP address is using as an identifier of a device, logical identifier. There are another physical identifier, which is MAC address. Okay, here we are talking about IP address. Okay, so IP address expresses two things. One is device identity. Okay, so what is device identity? Just you know that this device is IP address. It is one identity, and then the way the device is connected to the network. So IP address has a specific network part. Okay, which we differentiate in case of IP version 4 or IP version 6 also with prefix length. Okay, or CIDR notation. Okay, so that represents that this device is connected to this network. Okay, so IP address actually represents two things. Okay, it's clear. So but LIS routing architecture design separates the device identity and endpoint identifier or location routing location onto different numbering space, splitting endpoint identity and routing locator functions in several. Okay, it is okay. If I discuss, then it will be clear. Otherwise, it will be different. Okay. So at first, understand the different terms. So LIS is actually used for control plane protocol in software-defined networking. So fabric nodes has different endpoint identifier EID Okay, look at this details. Endpoints is traditional means based on their MAC address. Okay, individual IP address by subnet. Identifying each endpoint with endpoint identifier. Okay, understand one term, endpoint identifier. Endpoint identifier means one IP address. It has also related MAC address. So these are the identifier, endpoint identifier. Whether it is your tablet, whether it is your mobile, whether it is your server, or no matter what. Okay. So you have endpoint identifier, one thing. Okay, just remember endpoint identifier. And then we have data. Okay, here we have endpoint identifier database called list map server. Okay, again remember list map server. Okay, I will discuss with this term. And map server keeps what? List of endpoint identifiers and matching routing locators, which fabricate nodes can reach that. Okay, what is the list map server? Map server just keep records of endpoint identifiers. Okay, and matching routing locators where those devices are connected. Okay, in future, Fabric data plane needs to forward a message. It will look for and find the destination in Lisp server Lisp map server database. Okay, look at this picture. Say in the network, you have three switches: switch 1, switch 3, and switch 4. And you have Lisp map server. Okay, and there are networks 10.1.3.0/24 network. There is 10.1.4.0/24 network. There are RLOC. RLOC is routing locator. Say you have switches. Switches have their IP address, their own IP address. Say one RLOC is W3, switch 3. Switch 3 has 172.16.2.3.3, and another switch 4 has 172.16.4.4. Okay. Okay. Now, what Lisp server, Lisp map server does actually, it keeps a database. Endpoint identifier network 10.1.3.0/24. Where it is connected? It is connected to RLOC 3, switch 3. What is the IP address? 172.16.3.3. And what about 10.1.4.0/24? It is also connected to 172.16.4.4. Okay. It is a database. Okay, and another term you should remember: ingress tunnel router. Switch 1, and okay, switch 1 is ingress. That means something will be connected to as some endpoint will be connected to SW1 that wants to connect to somewhere, say switch to some devices connected to switch 3 or switch 4. Okay, so Lisp map server kept database where all the networking data are recorded. Okay. What is the benefit of this recording? Okay, okay, let's discuss here. Okay, okay, no other figure here. Okay, why it keeps the database? What is the benefit? Imagine some endpoint wants to connect which is connected to SW1, and it wants to connect some devices connected to SW3. So imagine some IP address of 10.1.3.0/24 or IP it wants to reach. So destination IP address is 10.1.3.1. Okay, of that network. So want to connect, how it will do, what it will do. So switch 1 will contact list map server, will ask, I want to reach this device, where it is. Okay, the device will say, okay, send your tunnel VXLAN or establish a VXLAN tunnel with 172.16.3.3. That means switch 3. Connect to switch 3, you will get. Okay. And then what switch 1 will do? Okay, switch 1 will just establish a VXLAN tunnel with switch 3. Okay, it will pass this layer 2 frame to switch 3, and switch 3 will have its ARP table, for example, or not ARP, at a MAC address table. It will transfer its MAC address, ARP protocol will be there. Or for that IP, it will transfer the frame to the specific endpoint. So in this way, a list server just ensures all the information for your VXLAN tunnel. So list is used as control plane. Yeah, okay. It just controls where you send your VXLAN tunnel, or to which device you will create a VXLAN tunnel. Okay. So in between, there are different nodes. Okay, you know that switch 1 and switch 3 is not directly connected. May be connected, no problem, but chances are that it is not directly connected. There are many several switches in between. So they will not look into the VXLAN traffic. They will just pass through them. Okay, pass through themselves to the destination. Okay, they will not look into. They will just look at IP address. Okay, this VXLAN packet has come to me. Okay, where I should send? Okay, I will send it to them based on the routing table. Okay, ISIS routing table, or OSPF can be also used, but in most cases I saw this is preferred protocol. ISIS is preferred protocol. Okay. Okay. Generally, in a simplified version, these are the concepts you can study further for in-depth knowledge. Okay. So we have to go more topics. I'll just start. Okay, REST API I have already discussed. What is API? API is used for exchanging information between applications. Okay, you have several applications or microservices, and you want to transfer data between them, and those applications are in different, installed in different servers, maybe, or may connect to our internet. No problem. If it has network connectivity, API can communicate or exchange information between the servers, regardless of which programming language or platform or framework used by the programmer. Okay, they have a common language. Okay, that is API. So there are different types of APIs: SOAP API, REST API, or more. There are different types of API, but I will not go to details. Which is most modern and commonly used API is the REST API or RESTful API, representational state transfer API. If you are a programmer, you are more familiar with it than me. Okay. But to fix those APIs, REST API 6 attributes or characteristics. Okay, it works as client server model. One side of the program will act as server and another client. Imagine you have made a application, and at some point where you want to show the market price of a share of that company. Okay, you have a small dashboard in the website you develop. Okay, so you will use the API from stock exchange website, and you have to request them to provide an API, and you will integrate your API. In that case, your web server will be the client of API, and the server will be the stock exchange server or application will be act as a server. Okay, this is client server model. And a stateless operation, stateless means it will not keep record when you are sending data or receiving. Normally it will not, it may not keep a state. Okay, and again you will request, I need this data, and it will transfer the data. Okay. Imagine, okay, consider the same example of stock exchange. What is the value of this share right now? Okay, it changes instantly. Okay, so API gets one value, and again if it requests value, and it will deliver another value that is available at that time. Okay. So it is a stateless interface. Clear statement or cacheable or uncacheable means it can be in cache or cacheable. For example, some can be cacheable, some should not be cacheable. Some, for example, in case of stock exchange value, it changes continuously. Okay, so it should not be cacheable. Cacheable means it can deliver value from cache, which is without querying in the database. Okay, so it should be uncacheable. What should be cacheable? Say static data, which is actually fixed. Okay, in that case, cacheable data can be transferred. Uniform interface, it has the same interface for all kinds of application. Okay, layered, it can be layered. Different layer has different value. And code on demand. Okay, it can provide code on demand facility. Okay, so what I said, what is client server operation here? Say client request, client will request always. Okay, client sending a API request to server. I need this data. Okay, what data? It will be mentioned in HTTP verb. What is HTTP verb? I will discuss shortly. HTTP in the HTTP, you also mentioned URI, uniform resource identifier. That means you will mention from where your data will be sent to you. Okay, you will say that I need that data. Your client application say, okay, what your REST server will do? REST server, REST application, and will or you or server or application which act as server will deliver that value in response. Okay, it will respond with the value. Okay, So it is a packet that will be transferred to the server, and server will transfer a packet. Packet is as usual, it is IP packet, it has TCP header, it has HTTP field. HTTP, in HTTP field, it has verb, it has URI. Verb means what it wants to do. Okay. HTTP bars are, there are different HTTP bars means actually here actions or tasks. So crude term is create, read, update or delete. Okay. Crude operations are done using REST API. Say using REST API, you want to create new data structure or variables. Okay, you want to create new thing. In that case, you will post. Okay. It is and or you want to read some value. You get. So if you want, if you get server from a share, okay, and this okay, you want to get. What will be the action when you want to create new data? That will be post. Okay. Or sometimes you need to update the data. Say you want to change your name for some reason. Maybe there was mistaken or spelling mistake in your name in the server. In that case, you will update. Okay. Or sometimes you want to delete some data that is not necessary or unnecessary. Okay. You delete. So crude operations are performed by API. And what is API? API looks like this type of URI, HTTPS :/, then your host name, and then your path resource location, then you query specific data. Okay. So when you want to get an API from the server, they will provide you this, and you will integrate this in your client application, which will query data from server application. Okay. So just for understanding, I give you this. Okay, then another two concepts are remaining. We'll cover very soon. Okay, data serialization language. Say our network, we send different data to other applications. There are different proprietary versions of exchanging those information. That was quite difficult. Okay. For compatibility, one system was compatible, another was. So there are some common languages. We have 3 languages are common nowadays: on JavaScript, object notation, JSON, REST API, which is used in REST API. Okay. And we had XML, extensible markup language, which use SOAP API. Okay, you may know SOAP API, simple object access point API was another version of API. Okay, that is XML, and we have also YAML. YAML in the markup language. YAML is also used by Ansible. Okay. So these types of languages are there. So how JSON look like? JSON look like this: a key value pair. Key means here type. What is type? what type of the device? Cisco and Catalyst 9000 switch, family, switches and hubs, role, access, MAC address, then MAC address mentioned, name, host name, then host name is Cisco cat underscore 9K underscore 1. Okay, so key value pairs are there in JSON format. Okay, JSON document. Then we have XML. Most of you may work with HTML for web. Then you are familiar with HTML, and XML is a variant of HTML. Okay. And then you have YAML language. YAML is also okay. What is the difference between them? The same thing can be represented by using all those languages, but their style is different. Here, key is in inverted comma and value is inverted comma, but they have a colon in between, and each key value pair has a comma. Okay. And they are packaged in parentheses, curly bracket, and okay, it is the syntax you will go through. Okay, and what about XML? XML has different angle bracket key value presentation. And then it has some similarity in HTML, similar to the HTML, and we have YAML. YAML has another format. It uses hyphen in the beginning, then a key, then its value, then colon, and then more details are indented inside. Okay, in the indented to the right side. So okay, all this hyphen and indentation are significant. I find YAML is more difficult, although YAML is more understandable compared to XML. Actually, JSON is interesting to me, but you may feel differently. Okay. So why we are talking about this? When we configure different devices with automated system, which we'll discuss very soon, we will use this data serialization languages for transferring configuration data. So when you have so many devices, imagine you are working in a very large networking company. Don't think that you are working at a small company where you have a very small number of devices which you can manually log in and manage using SSH Telnet or HTTPS, no problem. But when you have 500 thousands of devices, what you can do, then you have some challenges in configuration. On device manual configuration process does not track change history. Okay, it is a challenge. That means there are one challenge is that there are many network engineers in an organization who work on the same devices. So they are changing when a requirement comes, but another engineer goes to there and another changes there. But some changes may not be required after some time, but those configurations are still there. So this is a problem. So there is no track or there is no accountability of this type of activity. So what is the solution? Solution will be centralized configuration files and version control. So you know who you will develop software, you know about GitHub or GitLab. Okay, where you can control your version. Say keep a version, then you create another version. So you can keep track of those versions so that you are not confused with old, new, with old and new versions. Okay. Okay. So here we can also use this kind of configuration file centralized management or version control mechanism like GitHub, or we can use it in our own application, which is similar to GitHub or GitLab or kind of, okay. And there configuration drift. Configuration drift means over time configuration may change unnecessarily. Maybe your different colleagues or team members are working on the same thing, so same router or switch, and over time the intended configuration will not be there. There will be a different. So what you can do, you can monitor, you can ensure that the configuration is right through monitoring and police enforcement. And the configuration provisioning is another challenge. Using configuration templates and variables can be used. Configuration provisioning means you when you are tasked to configure a router or switch, from doing the from beginning, just host name, IP address, interface, everything. Configuration takes time. So what you can do, you can use a template which are common. Some configurations are common for all, and there are some variables. Okay, you just create configuration templates and variables, and just change where changes are required. You will change and enforce this configuration to the new device. So within a minute or within few seconds, your device is ready for integration. Okay, so all these are performed using automated tools. In case you have many devices and you want to make automated, you want to make sure that only authorized configurations are allowed. In many secure organizations, you are not allowed to configure any devices whatever you want. There are some policies. At first you will configure or make a script, and it will go through vetting. Your senior or security experts will scrutinize or check your configuration, and will give their opinion, or sometimes ask you to change some statement or add some features, so that the configuration of devices follow the organization's policy and they are secure for the organization or network. Okay, so this type of policies or procedures are used in that organization. So how you will actually implement those configuration in the actual devices? Use different automated tools like Ansible that I mentioned. Then we have Puppet, then we have Chef. Okay, you can use any one of them, but there are three tools. And those tools you can install on your Linux machine, for example. I don't know whether they support Windows. You can check their website, but in Linux you can install Ansible, Puppet, Chef, whatever you want. But they use different serialization language, and they use different protocols. They use be different. Okay, and someone feel comfortable with Ansible, someone with Puppet, someone with Chef. So it depends up to you which one you learn or which you feel comfortable. Okay. Okay, and in Ansible, how they configure a device, it has playbooks. Playbooks means it has some actions or logic. Okay, what they will do, what the configuration will do in mentioned in playbooks. And it has inventory. Inventory means say you have 5 new switches, you will mention 5 new switches in the inventory. So when you run the Ansible script, then those scripts will run on those 5 machines. Okay, or you can mention thousands of devices in the inventory. Okay, and you have templates. Templates is Jinja 2 language. It is also template, some kind of template. I will not go through them. You can read yourself. And Jinja 2 language is used for template for configuration and with variables. What is variables? Which say device name will be variable for different device. Okay, it is variable, but there are something same. Okay, so so these are the process of this, developing scripts in Ansible. After you are done with your scripts, and they are checked by at least another team member, especially experienced team member, who will say that okay, you can run the script, there will be no problem. Otherwise, this type of script will make a big mess, and your network will be destroyed. Okay, and this is the conceptual view of how an Ansible control node. What is a control node? Control node is on your laptop or computer, or where you install Ansible, and you create all the scripts and prepare everything based on templates and variables and inventory. And after finishing, you just push those templates to the router using HTTP. Okay, and the script will run and the configuration will be changed. So you can do it in the picture, just one router. You can do it for hundreds, thousands. Okay. And the Puppet is another tool, but their language is quite different. Terminologies are actually slightly different, but they are same. In the Ansible, we called it playbook. Here it is manifest. Okay, and there are resource class and module. Resource means here is what are the devices. Okay, inventory, here resources. Okay, templates the same. So manifest. Puppet is actually same, but Puppet script you can run with agentless or with agent. Okay, so Ansible is agentless. Agentless means you don't need to install any software on the device where the script will actually run. Okay, it can be agentless or agent based. Okay, it works with using API, but Ansible is agentless. So SSH protocol is already in the router. SSH server is already in the router switch. They just use that. So it don't need to install any agent. Okay, agent means a small software here. Okay, and we have Chef. Chef use a different language, kind of cooking resource recipe. Recipe means actually playbooks. Okay, and cookbooks. Cookbooks. Oh no, recipe means here determine when and how and whether act against the resources. Okay, cookbooks means here actually playbook. Okay, cookbooks guides you how you can cook your recipe. Okay, run list, ordered list of recipes that should be run against the event. Okay, so we are not going through details. So in a nutshell, you can see some differences. One is the term Ansible playbook is Ansible's language. Then Puppet use manifest, and SHAP is recipe and run list. Okay. Protocol to network device. So SHS and netconf can be used by Ansible. HTTP REST API is used by Puppet. HTTP API REST API are used by SHAP. Okay. And Ansible needs agent. Ansible can be agent class. Okay. Puppet can be agent based or third party agent. Okay. Okay. In the picture, here, look at this. Puppet is working with API, but there is using internal agent is used in router 1. In router 2, there is no agent, but there are another device in between Puppet and router. In the external device, there are some agent, and that agent is connecting the router using SHS, okay, indirectly. So there are push-pull method. Ansible just pushes the configuration, but in case of Puppet, you have to pull the scripts from the device. Okay, thank you. Okay, do you have any questions or anything? Actually, software-defined networking and all those automation systems are quite advanced level concepts. So you need to study further, or you need rigorous study to understand all these. But with this, if you understand that this material I just presented can be helpful to you and after that you will be able to advance your knowledge through further study or practical experience. Okay. Okay, let's take the attendance then. Okay, do you have any disconnect?
Actually, sir, I
Yes.
think this topics is wide, and
Yeah.
many important things are included in these topics. This is the advanced level, and I also saw that many language, that means XML, and in that language PHP also included, and JSON, YAML. That is very important. But YAML is this is the first time that I saw this type of language. But JSON and XML we already using in our campus.
If you use Linux, of course you should use Linux, and then you will see that Linux version, especially Red Hat Linux 8, which has changed for virtualization and cloud technologies, which included this YAML in Ansible and for automated scripting. Okay, you will see there. So okay, this is interesting. And you have also different converters. If you have one script in one language, then it can automated transfer to another language. Okay, but you have to learn how to write those. Okay. Okay. Do you?
Yes,
okay. Okay. If you have anything to add or discuss, you can. And I would say just go through, because you cannot avoid software-defined networking and virtualization and cloud in today's working environment. It's not possible because these are common nowadays. But when we started work, these are not actually that popular, or we just heard those names. Okay. That is an important point. Okay. So although these are quite difficult, but you should go through. Okay. Do anyone want to add anything more, or we just finish? Okay, I hope I took all the attendance. Yes, it is the
Sir,
last.
I have question based on our exam. In which day you will take our quizzes, and also what will be the syllabus?
Oh yes, it's a very important point. Okay, let's save. Where is my? Let's save that. Okay, what is regarding exam? I talked with our training coordinator Moshin. He told me that he will arrange a closing session, in-person meeting, where I will be given a certificate of completion. It would be better if we conduct the exam there. He will inform me. Arrangement or finishing closing session after the next session, and I will take a small quiz. That will be very easy, I would say. If you understand general
Your voice is lagging.
concepts, and after that, the exam will not be fair. No, maybe MCQ based. Say. So in that case, exam, how I conduct the exam? If I give some MCQ, maybe some will copy from another some material. That is the, in that case, it is pointless to take the quiz. Okay, if be great, where you will be present, you will be given a question, then you will be okay. I'll let you know. So don't worry about the quiz that much. But initially, one announcement or one update for you, that tomorrow I have a very important schedule. So due to this unavoidable issue, I cannot take your session tomorrow. Okay, I will take it day after tomorrow. That means on Sunday, 10 a.m. we will go for the last session. Okay.
Yes, sir. Sir, already motions are posted in our
Yeah.
Facebook group.
Yeah, yeah. I just remind you of this update. Okay. Thank you. Let's finish. We are already about David. Okay. Okay. Thank you all. Okay.
Okay, sir. Thank you very much.